Dear learners, you have already learned about natural numbers, whole numbers and integers. Now we will discuss about rational and irrational number. At first, what are the rational numbers? A number which can be put in the form of p by q, where p and q are integer and q not equal to 0 is called a rational number. For example, minus 2 by 3, 5 by 8 and 8 by minus 3 are all rational number because here all the case denominators are not equal to 0. Rational number may be positive rational number and may be negative rational number. Now, what is positive and negative rational number? A rational number p by q is said to be a positive rational number if p and q are both positive or both negative integers. If the integers p and q are of different sign, then q is said to be a negative rational number. For examples, 2 by 3, 5 by 6 and 7 by 9 are positive rational number. Here 2 by 3 means the numerator and denominator both are positive. In case of 5 by 6 also numerator and denominator are positive numbers. And minus 2 by 3, 5 by minus 7, 9 upon minus 8 are all negative rational number because either numerator or denominator one of the sign is negative number. Therefore, minus 2 by 3, 5 by minus 7, 9 by minus 8 are all negative rational numbers. Now question is, what is the standard form of a rational number? A rational number p by q where p and q are integers and q not equal to 0 in which q is positive or made positive and p and q are co-prime, that is when they do not have a common factor other than 1 and minus 1, is said to be a standard form of a rational number. For example, the standard form of 2 by minus 3 is minus 2 by 3 and minus 5 by 6 is 5 by minus 6. A rational number in standard form is also referred as a rational number in its lowest form. For example, the standard form of 18 by 27 is 2 by 3. Similarly, 5 by 9 is the standard form of 25 by 45 because 2 by 3 is the lowest form of 18 by 27 and 5 by 9 is the lowest form of 25 by 45. Now we will discuss about equivalent forms of a rational number. The equivalent form of a rational numbers are obtained by multiplying or dividing the numerator and denominator of the given rational number by the same number. For example, 2 by 3 equal to 2 multiply with 3 upon 3 multiply with 3. That is a constant quantity. 3 is multiply both numerator and denominator and the product we get 6 by 9. So a rational number have a infinite equivalent form. Now we will discuss about the representation of rational number on number line. As you know that the natural number, integer and whole number all are represented on number line. Similarly, any rational number can be represented on number line. For example, we are taking in 1 by 2 or minus 1 by 2. See the figure and you know that from 0 onwards means from 0 rightwards you will find all number are positive and backward, that is from 0 left side all numbers are negative number. You see the figure OP and OP is exactly half of OA and from the figure you find OA is nothing but the 1 square unit. Therefore OP exactly half of OA, which is nothing but 1 by 2. That is half, and we will be similarly we follow the left hand side, we will get OR is nothing but minus 1 by 2. Similarly in figure 2, 4 by 3 can be represented on number line as follow. That is from 0 onwards you will get 1, 2, 3, 4, and left hand side you will get minus 1, minus 2, minus 3, and the located point is 4 by 3. Now we are going to discuss on about the comparison of rational number. Rational number are compared with each others. If two rational numbers to be compared have the same denominator, compare their numerator. The number having the greater numerator is the greater rational number. For example, between 9 by 17 and 5 by 17, here as the same denominator, that is 17, and numerator 9 is greater than 5, therefore 9 upon 17 is greater than 5 upon 17. If two rational numbers are having different denominator, first task is we have to make their denominator equal by taking their equivalent form and then compare their numerator of the resulting rational number. The number having the greater numerator is the greater rational number. Now we are going to compare between 3 by 7 and 6 by 11. Which is greater? In this case, what will you do? At first, 3 by 7 in denominator you multiply with 11 and numerator also you multiply with 11. You will find 3 by 7 equal to 33 by 77. Similarly, in 6 by 11, you multiply 7 in both numerator and denominator, you will find 6 by 11 is nothing but 42 by 77. Here we compare with 33 by 77 with 42 by 77, as 42 is greater than 33 and the denominator both the cases are same, that is 77. Therefore 6 by 11 is greater than 3 by 7. Now we are going to discuss about decimal representation of a rational number. The process of expressing a rational number into decimal form is to carry out the process of long division using decimal notation. Case 1. Using long division, you will find 12 by 5 equal to 2.4 and 13 by 6 equal to 0.812. When the remainder become 0 after a finite number of decimal places called a terminating decimal. Case 2. The decimal expression of 7 upon 3 equal to 2.333 up to infinite. That is 3 is repeating after one decimal number, and 5 by 11 equal to 0.454545 up to infinite. That is 4, 5, 2 digits are repeating after 2 digit 45. From both the case 1 and case 2, it is found that the decimal representation of rational number is either a terminating decimal or a non-terminating repeating decimal. But some cases you will find neither of the decimal expansion is terminating nor is repeating. Such decimal expansion of a rational number is called irrational number. For example, 0.1010001000 up to and 0.123456 ... which are neither terminating nor repeating. Such number are called irrational number. That is root 2, root 3, root 5. Its decimal expansions are neither terminating nor is repeating, which are called as irrational number. Similarly, irrational number can be representation on number line. Take root 2. Here the representation of root 2 on number line is the distance O to O dash, which is nothing but equal to OP. So OP is the exactly distance root 2 and P is the location of root 2 on number line.